Welcome back, students. We are about to begin section 3 of this notebook, Values of Trigonometric Functions. But before that, let's have a bit of a review. The very first thing we did was to define the angle. How did he do that? Starting from a unit circle, a circle of radius 1 centered at the origin, we defined the radian measure of the angle as follows. The distance of a counterclockwise travel from the initial point, 1, 0, the right-hand side, to the terminal point x, comma, y, the tip of this arrow here. Or equivalently, arc length in counterclockwise direction. If we measure clockwise arc length, then the angle is negative in that case. Okay, I like this picture. Now, what if we have a circle with arbitrary radius? If the radius is not 1, what do? We have a situation like this. And we have two different radii here. Of course, we could consider even more circles, 3 different or 4 different, but end result is the same. Angle turns out to be the distance of counterclockwise travel from the initial point r, 0 to the terminal point x, y, but divided by the radius r. So if we have 2 different radii, then we have to have 2 different arc lengths. But if we take the ratio, it should be the same, and that's the angle. By the way, the fallout of that observation is this. Ignoring the sign, angle theta is given by arc length over radius. So arc length is r times theta. From here, we were able to define trigonometric functions. How did he do that? Well, this is the way we did. We draw, I don't like this picture very much. Okay, this one is a little bit better. We have any angle. And then we have inscribed triangle, kind of like this, of course. And sine, cosine, and tangent we defined as y over r, x over r, and y over x respectively. Radius r is always positive, and x and y are sometimes positive, sometimes they aren't. In this particular case, when the terminal point is in the first quadrant, x and y are both positive. So all sine, cosine, and tangent are positive. However, in this case, it's a little bit different. This time it's in 4th quadrant. I'm going to the right, so x is positive, but y vertically is going down, so y is negative. So cosine value must be positive, sine value must be negative, tangent must be negative. Let me remind you again, r is always positive because that's the radius. It's x and y that causes the change of sign. Cosecant, secant, and cotangent are just reciprocals of sine, cosine, and tangent, so they're not really important. We are going to consider only elementary trig values most of the time here, sine, cosine, and tangent. Whenever we have cosine, cosecant, secant, and cotangent, we will convert them into sine, cosine, and tangent and go from there. By the way, we talked about signs. When x and y are positive, here's a summary. A smart trig class, and here it is. In this particular case, all positive. X and y are both positive in the first quadrant. In this case, 4th quadrant, only cosine is positive because x is positive, so x over r is positive, but y is negative, so y over r, sine is negative, y over x, that's also negative, tangent is also negative. How about in this case, 3rd quadrant case, x and y are both negative, so y over r, x over r are both negative, so cosine and sine are both negative, but tangent, we have y over x, that's negative over negative, so end result is positive, so tangent is positive. Kind of like this, and the summary is a smart trig class. The summary is a smart trig class. Now we talked about the sign, pluses and minuses of trig values. Let's consider the magnitude. We cannot always find out the precise values, but sometimes we can. And those are the special values that we are interested in, and they are summarized in this diagram here. In this wheel diagram, the first coordinate is cosine, second coordinate is sine. So if you want to find out, for example, cosine of pi over 6 or cosine of 30 degrees, well, find out 30 degrees or pi over 6 and then get the first coordinate. That's square root of 3 over 2. What if you want to find out sine of 2 pi over 3? Go to second quadrant, 2 pi over 3 and 120 degrees, and sine is second coordinate. So sine of 2 pi over 3 is square root of 3 over 2. You can find out all those standard trig values from this diagram. And if you want tangent is sine over cosine. So you can always find out tangent value by taking a ratio between the second and first coordinate. The question is why? Well, okay, I mean for average or below average students, just memorizing this formula is going to be enough, but for a little bit more serious students, let's consider the derivation. And this way you can use your brain and you can use critical thinking to study rather than just blind memory, which you'll forget anyway. And all you have to do here is remember just two triangles and one line segment to tell the truth. And we begin with a line segment here, a degenerate triangle. Angle is 0, so we have this red line segment here, and it's reproduced on the right hand side, and height is 0, so vertically we do not go up, so we don't have triangle, we end up with a line segment, and that's how we get sine of 0 is 0. Cosine of 0 is 1 because x value is the same as the radius. Tangent is sine over cosine, so that's 0. Just too trivial. The next case is going to be a little bit more interesting, and here it is. Our old friend 1 square root of 3, 2 triangle, and this is one side of an equilateral triangle. Consequently, we have the sine, cosine, and tangent value is 1/2 square root of 3 over 2 and 1 over square root of 3. The next one, pi over 4 or 45 degrees. In this case, we have to look at this triangle, 1 square root of 2 triangle. How about 60 degrees or pi over 3? Do we have different triangle? Actually, no, it's the same triangle. 1 square root of 3, 2 triangle again, but positioned a little bit differently. And this strategic position at 60 degrees on the origin side, we get these trig values, square root of 3 over 2 for sine, and 1/2 for cosine, and then square root of 3 over 1 for tangent. Next one, pi over 2. In this case, we have another degenerate triangle here. We have just vertical line segment like this. And of course, vertically, we just go to the radius. So y over r is r over r. So sine of pi over 2 is 1. Cosine, on the other hand, is 0 because horizontally we don't go anywhere. So cosine is x over r. That's 0 over r. That's 0. How about tangent? Tangent is undefined because sine over cosine, we have 1 over 0, that's undefined. What if we go over to the second quadrant? Do we have different triangles? No, not really. It's the same old 1 square root of 3, 2 triangle positioned appropriately like this. And consequently, we have some negative signs like those, but we already covered those negative signs. A smart trig class. How about 3 pi over 4 or 135 degrees? Again, the same triangle we saw before. 1 square root of 2, 2. 1 square root of 2 triangle, excuse me. How about this one? Another new triangle? No. The same triangle all over again. 1 square root of 3, 2 triangle. And that's going to be the recurring theme for the other quadrant 2, same triangle we saw before, positioned appropriately to our third quadrant, or kind of like that, or kind of like this, in this case, fourth quadrant. In short, you don't really have to memorize too many. All you have to know is, well, all you have to know are two triangles. One square root of 2 triangle, and one square root of 3 2 triangle. Just position them appropriately and think, and you can get your answer. If that's too hard, then you'll have to memorize this. You'll have no other choice. But my preference is to think and use critical thinking skill rather than blind memory or using formula sheet. How about some other problems here? Evaluating the expression. There are a lot of problems like this in our textbook, but I think that's going to be a kind of relic from old days when we have to do the computation without calculator. Nowadays, just use calculator. Just remember to set your calculator in radian setting, and remember to convert those decimals into appropriate square roots. Getting angle back may be a little bit trickier. For example, what if you want to find that cotangent is negative square root of 3 in this angle? Well, between 0 and pi, so we are looking at either 1 or 2, first or second quadrant. Cotangent is negative, so tangent is negative, so it should be second quadrant. And then all you have to do is go to that diagram here, second quadrant, and when do we have cotangent in negative 3? Negative square root of 3, excuse me, that is x over y is negative square root of 3. Well, that's going to be 5 pi over 6, or 150 degrees. Those are a little bit harder, but still easy enough. Let's consider these type of problems now, and these are going to be more challenging and more important, and calculator will not help you very much. You really have to think this time. Cosine is given like this, 2/3, and actually there are two information. One is cosine is positive, and the other is cosine is 2/3. Cotangent is positive, so what quadrant do you get? Cosine is positive, so and tangent is positive. We are looking at the first quadrant. In the first quadrant, x over r is 2/3. In the first quadrant, let's draw a triangle with x is 2, the radius is 3, kind of like this. And you can find out the height using the Pythagorean theorem. Square root of r squared minus x squared. You're going to get square root of 3 squared minus 2 squared, which is square root of 5. Once you have x comma y like this, x is 2, r is 3, and y is square root of 5 now, you can answer all the trig function values directly from the definition. Sine is y over r, cosine is x over r, tangent is y over x, and so on and so forth. So get a quadrant, and then draw the triangle, and then you're through. Let's do this just once more. How about this problem? Cotangent is 3/7, so that's positive. Secant is negative, so cosine is negative. What quadrant is it? Not first. And cotangent, tangent is positive. You're looking at the third quadrant. In the third quadrant, we have to draw the triangle with cotangent is 3/7, like this. Horizontally 3, vertically 7, and using Pythagorean theorem, we can find out the radius. If you have x, y, and r value, you can easily find out all the trig function values just by the definition, and here they are. The other problems are similar. Step 1, find out the quadrant. Step 2, draw the triangle and find out all the trig values.